Started. To begin factoring, by the way, I should give you a definition of factoring. The process of writing a polynomial as a product is called factoring. As a matter of fact, the process of writing a number as a product is called factoring. If you write 12 as 3 times 4, you just factored 12. Now, you may be asking, what if I wrote 12 as 2 times 6? Well, you also factored 12 because you wrote 12 as a product. So we're going to practice factoring polynomials. And leading up to that, the first step to factoring will be to look for a greatest common factor. So let's first talk about that in terms of integers. Let's look at some steps we can use to find the greatest common factor of a list of integers. Find the GCF, the greatest common factor of a list of integers. Step 1, write each number as a product of prime numbers. Now, if you forgot, and I'll go over this again, a prime number is a natural number other than 1 whose only factors are 1 and itself. But that's step 1, write each number as a product of prime numbers. Step 2, identify the common prime factors. And step 3, the product of all common prime factors found in step 2 is the greatest common factor. If there are no common prime factors, the greatest common factor is 1. All right, so by the way, I did mention prime number. We have talked about prime numbers before, so I hope you remember. But in case, a prime number is a natural number other than 1 whose only factors are 1 and itself. So all this will start coming back as we start working exercises. So let's look at the following exercise. I want to find the GCF, the greatest common factor of 36 and 90. And don't forget what greatest common factor means. I'm looking for the largest number that's a factor of 36 and also a factor of 90. Now, after we work these for a while, you'll start being able to recognize, at least for smaller numbers, recognizing the greatest common factor just by sight. But right now, let's learn a method so you'll have something to go to in case you don't know what the greatest common factor is by sight. So here I've got 36 and 90, and greatest common factor. First, we'll write each number as a product of primes. Now, how you do this is certainly up to you. I usually just think of two numbers whose product is 36, and I'm not including 1. Remember, 1 is not a prime number. So 36 is, say, 4 times 9, but 4 is not a prime number. 9 is not a prime number. So let's see. What is 4 as a product of prime numbers? 4 is 2 times 2. Those are prime numbers. 9 itself is not a prime number, but 9 is 3 times 3. So can you see that I've written 36 as a product of prime numbers? That's one method of finding a prime factorization of a number. Another is you can take the number itself. It's just a different look, really, same idea. Think of two numbers whose product is 90, and we do not want 1 as one of the factors because we're looking for prime factors. 90 is 9 times 10, okay? If your number is prime, you just rewrite it, but 9 is not prime. 9 is 3 times 3. Okay, so 9 is 3 times 3, and then 10 is 2 times 5. And these are all prime numbers. So I now know that 90 as a product of primes is 3 times 3 times 2 times 5. This is kind of just a little tree method of finding the prime factorization of a number. All right, so let's go off to the side. I know 36 as a product of prime numbers is 2 times 2 times 3 times 3. These just happen to be in order. I wrote them in numerical order, but you do not need to come out with the correct greatest common factor. 90 is, as a matter of fact, let me just write these in any order. 3 times 3 times 2 times 5. Okay, so I've accomplished step 1. I've written each number as a product of prime numbers. The next step is to identify the common prime factors. In other words, let's see, notice there's a 2 in 36. I like to circle them to make sure I don't use a number twice. There's a common prime factor of 2 in 36 and 90. I don't have a 5 in 36, but I do have a 3. There's a common prime factor of 3 and another common prime factor of 3. So the greatest common factor is step 3, the product of all common prime factors. So I had a common prime factor of 2, I had a common prime factor of 3, and another common prime factor of 3. So even though they're common, and we circled, for example, 2 3s, I just count the common factor once. So my greatest common factor is 2 times 3 is 6 times 3 is 18. What does that mean? That means 18 is the largest number that is a factor of 36 and is also a factor of 90. Another way of thinking of this, 18 is the largest number that divides into 36 evenly, and it divides into 90 evenly.